Okay, sounds good. So welcome to the SI session. I feel like it's just going to be you today, but that's totally fine. And then once we get more students, we'll catch them up. But the plan for today is that we are going to be doing a little icebreaker. It's going to be the diatomic molecules. This is something that you have to remember. So we'll practice that, and then we will be naming some compounds and acids. So have this list that we'll try to maybe name during the session, and then we'll do like a 3 electron dot structures, and then we'll do a closing. And then again, just a reminder that I'm gonna have another session on Wednesday from 2:30 to 4 p.m. But let me share this document with you first, and then we'll get started. Okay. Okay. Here you go. Here's the link. Let me know if it works.
Wait, is it just me?
Yeah, actually, let me remind you something. I'm sorry. I should have mentioned this in the beginning. So for the alternative or the SI session, I can't have you turn on your mic or video, but that's okay. It happens. This is only the second one. So we will communicate through chat. Hello, looks like we have one more student. So let me explain the agenda for today. Basically what we're going to do is we're going to do an icebreaker on diatomic molecules. We'll be naming some compounds and acids. So this is like the list that I prepared. We'll do some electron dot structures and a closing technique. And then just a reminder that I'm gonna have my session next Wednesday, 2:30 to 4 p.m. And then what we're going to do right now is diatomic molecules. So I want you guys to kind of remember how it looks like. I'm gonna mute everybody so I can't hear any like extra sounds. So for the first one, let's kind of remember which diatomic molecules there are. So there are 7 of them. So if you remember them, please list them here, and then we'll go from there. So if you feel like you are not quite sure, so this is from the lecture from Wednesday. Dr. Tran kind of went over briefly the 7 diatomic molecules that we have to remember. So try your best. Maybe you can give me like a thumbs up or a yes or no in the chat. And if you just joined, here is the link to the worksheet. And we just went over diatomic molecules right here. Okay, so that is pretty good. And then we have some agreement in the chat as well. We have H2, we have N2, O2, F2, Cl2, Br2, and I2. So I do actually have a mnemonic to memorize this. So there is one mnemonic that you can use to memorize this, and then there is like the periodic table. You can kind of remember the trend. So let me add those 2 pictures here. that you can kind of use to remember this. So, and then I'll explain kind of how it works. Okay, so I have this one, and you can also use this other picture that I have. Okay, and now we'll just quickly explain it. Okay, so for the first one, as you know, you can memorize this by heart. However you're memorizing it, you can use flashcards or anything, but I like to use this mnemonic. So the way this mnemonic works is that you have this whole list right here, and then you just use the first initial of all of them to kind of memorize it. So the first initial for hydrogen is H, and then nitrogen is N, fluorine is F, oxygen is O, iodine is I, chlorine, you just memorize it by C. So don't confuse it with carbon. And then we have bromine, which is B, and then make sure you remember it by B means bromine, not boron, because that's how the elements work. So, and the way you memorize it, your mnemonic is have no fear of ice cold beer. It's very catchy, you can remember it. And then you'll just, if you know this, you can list out the other elements. Does that kind of make sense to everybody? Let me open the chat, disappeared. Yeah, okay, looks like it works. And then another way you can memorize this, you'll just memorize this like L looking downwards. So you'll know NOF, and then these four elements right here. So 4 and 3, you can memorize it by that, and then you have hydrogen. So make sure you don't forget hydrogen. So this opposite looking L and then the hydrogen, but make sure you know the placement of it. So it's from nitrogen to iodine. That's how I memorized it, but looks good, everybody. So now what we're gonna do is we're gonna be naming compounds and acids. So there isn't, so like a kind of trick to do these, like kind of what I went over in my Wednesday session, is make sure you know the prefixes, first of all. The prefixes are like mono, di, tri, tetra, and so forth. So if you want, you can look back to your notes from previous session or your lecture notes. So you can memorize those. And then the other helpful thing to do these naming and writing formulas is having a worksheet for polyatomic ions. So as you can see for this one, for example, we have NO3. That is a polyatomic ion. You don't have to memorize this. You'll just know, you'll just have to learn how to apply it into the formula. So that's just kind of like my tip to do this. But what we are gonna do, so then since there's like, let's see how many of us. Okay, so we'll do it as we go. So let's do, so each one of you will do one and then we'll go for it. So whenever you feel ready. And we'll do it in portions of 3s. Actually 4, so there's 4 of us. Good, so we have calcium, which comes from Ca, and then we have oxide from the oxygen. And just to make sure that, kind of like for chemistry, you can check your work, whether you're doing it right or wrong, right? So make sure you also signify like which are the kind of the charges for each one of them. So we'll go ahead and list those here just in case. So what's the charge of calcium? Does anybody know? You can just put that in the chat if you know. Yes, it is 2 plus. Good job. Okay, so basically the way we find it is from the periodic table. So group 2, all of these are going to have charge 2. So that's why our calcium is 2 plus. And then what is the charge for oxygen? Yeah, so oxygen is, so these ones are kind of tricky. So let me kind of refresh your memory for like how the charges kind of work. So all of these are 1. Okay, you got it. So it is -2, and then, but I'll just explain it for everyone's, you can kind of refresh your memory of it. So group 1, all of these are +1, all of these are +2, all of these are +3. This one is, it can be either +4 or -4. You won't necessarily have to deal with this as much. It's just not that common. And then we jump here, we ignore the noble gases here. So all of these ones are -1, -2, and then -3. And then again, this could be +4 or -4. So just note that down in your periodic table because you will have to memorize that. You have to know which group corresponds to which charge. So, okay, so we established that it is -2. So let me type it here. Yeah, so as you can see, it's 2 plus and 2 minus, so that just cancels it out. So your formula is just going to be calcium oxide. You don't have to deal with any other thing. So now let's go to Al2 and then O3. So what is Al a symbol of? The element's name. So Al is right here. Yes, it is aluminum. Thank you for replying. Okay. And then O, like just from the top, it's oxygen. But what do we write it as? Do we write oxygen or do we do something to it? Element, we keep it the same, just like how the elements are for all of the periodic table. So we keep the calcium, but for the second element, we change the ending. So we change the oxygen to "ide". So for here, we're gonna do the same thing. It's gonna be aluminum oxide. And then the charges you can kind of see from here. So does anybody want to tell me what's the charge for aluminum and what's the charge for oxygen here? I just want to mention that if I were to do this, I could do this, but I need a little bit of participation so we can move forward together. I know it's a Sunday morning, you don't want to talk as much. Formulas. How do you find the charge is that you will be switching. So kind of like the practice from Wednesday if you were able to attend the session. But if you weren't, that's totally fine. So for aluminum, we see that it has aluminum 2 and then oxygen 3, but the charges are switched. So when we're writing the formula, so the charge for aluminum is actually 3, it's not 2, even though it says Al2, it is Al3. So we're gonna put Al3 plus, and then oxygen is 2 minus. You can either look at this, the switching kind of to make sure what the charge is, or you can just go to your periodic table and see what the charge is. So you'll see aluminum is in group 3 category, so it is 3 plus. And then oxygen, we kind of found it already too. It is in the category here, which is 6A, but we switch it, so -1, -2, -3 kind of. So oxygen is -2. And this is how we write the formulas. So if you kind of know this, you can switch. The way I like to remember is you kind of switch the partners. So you switch the 2 and then the 3, and then it will come, the formula will come out as Al2 and then oxygen 3. And the reason why we're doing this so that the net charge is 0. Yeah, so this is how we do the formulas for these two. But so these two, yeah, no problem. So these two are actually your acids. So this is something that you have to memorize. If you don't have it memorized yet, I just want you guys to just look at your notes and kind of see which strong acids and strong bases there are. And then if you know the answer, please put it in the chat. And again, if you feel comfortable putting the answers in private chat, it's okay. I don't mind. Yeah, I can kind of run over this too. So basically for this, majority of it, it's memorization. So you can do like flashcards to kind of memorize this, but there is like a bit of a strategy on how to kind of find these answers. So we have hydrogen. So let's write hydrogen here. And then you have Br, which is bromine. This is something that you kind of remember for before your last midterm, that we have to memorize these elements. So that's all I have right now. So for all of kind of the acids, you know how for these ones we change the ending to "ide," but here we're going to change the ending to "ik." So that's ICE. No, just IC. So let me kind of write it. So let's write it the same way kind of. So hydrogen and then bro mix. So this ending is just IC. And I can kind of bold it and then color it for you to kind of see the difference. And then we are not going to write the whole hydrogen. So we are going to kind of section it out a little. We're just going to write bro, kind of like that. So this strategy works for majority of them, but it doesn't work for this one. So this one, we don't write the hydro. You know that we have Cl, which is, let me make it bigger, which is chlorine. And then, you know how I was saying that you make them ick, but not for this one. So this is like the exception kind of rule. For this one, it actually comes out to chlorus. This is how you write it. So it's kind of like, you can't have like a strategy behind it, but not for this one at least. If there are any others, okay, we'll do, there are a few, so we'll do those. We'll use the strategy later on, kind of. So these ones, acids, we won't worry about it too much yet. Oh, the question is, how do you know if it is an acid? So for acids, basically we have this H in the beginning. This H basically kind of symbolizes acid. For bases, you're gonna have OH. So I can kind of write it here in the notes. So H plus kind of signifies acid, and then you have OH minus, that means base. And here's the mu. Yeah, that's a really good question. Yeah, keep that in mind when you're doing the acids and basics. And for the question, and if it's when do you know to put the IC? So basically, it's kind of like memorization. There isn't like a trick to know which ones there is, but basically, to kind of put it into perspective, you only have to memorize the strong acids and the strong bases. And I believe there's only 7 or 8 each. So it's not too much. If you just memorize those, you should be good for the midterm. So yeah, don't worry about it too much. Just like 14 total. That's all. So for these ones, you don't have to memorize anything. So let's see if how we do in these ones. So what is Mg? Can somebody write the element name in the chat? Yes, it is magnesium. Thank you. And so we know magnesium, right? And then we'll do the charges later on. But so basically now your worksheet from that has all the polyatomic ions is going to come in handy. So from that worksheet, tell me what is this NO3? So you don't have to memorize this, just look through the worksheet. What is NO3? And again, this worksheet is going to be on, in your Canvas, it should say polyatomic ions. Yes, it is in fact nitrate. Good job. So basically, that's the only thing you kind of have to worry about is you write the first element as it is, and then the second one that is in parentheses, you can get it from your polyatomic ion chart, and that's all. And again, to just for your understanding about the charges. So what if I just wrote, give me the formula for magnesium nitrate? The way you're gonna do it is you're gonna write the elements and then you're gonna put the charges. So you can actually know the charges from looking at the formula. So can somebody tell me what's the charge for magnesium? It's kind of like how we did this. Cross matching. Yes, it is 2 plus. Good job. And then basically the way we find 2 plus is you look at the charge right here because it has been cross-matched. And then you write NO3, and then you write the charge of NO3, which is it's 1 minus. Basically, you can see that there isn't anything here. That just basically means there is 1. And then you can also check magnesium here is 2 plus. So you will know that this one is minus. Okay, so good job. That was really good. Now let's go over the second one. So what is BA? What's the name of the element? Since there is only 2 of you, the pressure is on you guys to participate. I'm sorry, but like equations. And what's gonna happen as you go is the word problems are just gonna say either the name. So you will have to write the name first and then the formula and then you'll balance the equation. So the thing is that if you don't know how to write the formula from the name, you won't be able to write a balanced equation and then you won't be able to do mole conversions. So this is really, really important to understand. So all the questions that you have right now, please ask them because once we go into like the word problems, it's just gonna get more complex from there on. So does anybody know what is BA? Yes, good job. So yeah, BA is barium. And then the second part is phosphate. Yep, good job. Okay, so this one, P2O5, this is from like the prefixes that we did. So this one is easy. So let's see if we can do this one. So how will that work? Actually, it's not phosphate, it's phosphite actually. The phosphate has PO4. So yeah, make sure that you look at the ending very carefully. It's all really similar. until like the A and the I can make a mistake. Yeah, so this one is for the prefixes. So what's the prefix for 2? The ending rule for the polyatomic ions or this? Sorry, the question was what explaining the ending rule. Polyatomic ions. Okay, so basically, like you don't have to memorize the kind of the ending rule, like because for the semester, Dr. Tran is not requiring you to memorize the polyatomic ions, but just kind of to put it into perspective for you, is this is the amount of oxygens that you have. So when we say "ide," usually it doesn't have any oxygen, like it's just all by itself right here, right? And then we say nitrite, it may have 2 oxygens. So here it's NO3, so it's nitrate, but if it had only NO2, it will be nitrite. And then once it has more, then it's going to be nitrate. So 3 oxygen means nitrate, and then so forth. Usually 8 is the last one, but for phosphate, the rule is a little different. For when you have PO4, that is phosphate, and PO2 is phosphite, from what I can remember. Yeah, no problem. Yeah, so it's really like the worksheet is really handy as long as you can kind of know your way around the worksheet, you'll be fine. Okay, so do you guys remember the prefixes for like 1 through 10? Kind of run down it. So the prefixes that we have to know are, let me kind of create a table so it doesn't interfere with the formulas. So 1 is mono, 2 is di, 3 is tri, tetra, penta, hexa, hepta, octa, and tetra. Okay, so basically, again, this is something that Dr. Tran covered on Wednesday's lecture, if I remember correctly. You have to know these prefixes for when you're writing the formulas. So here, when you see P2, you will put di. And then when you're seeing 5, you will put penta right here. So the way it kind of works is like this. You will put di, and then what is P? P is phosphorus, diphosphorus, kind of, and then penta, and you use the same rule as above. Again, you write the first one as it is, and then pentaoxide. Does that kind of make sense? Okay, it makes sense. Good job. I know we will have another example. So, okay, let me have you practice this real quick. So what would be this one? So this one applies the same rule, and then we'll go back to the one we just left on the top. Here. You can see the example. These are the prefixes. Let me know what you will get for this one. Yes, good job. That is right. Let me make it bigger. Okay, one thing, so I know that you mentioned dichloride. So basically, the only thing is this, for this one, the first element, we put the whole name as it is, like from the periodic table. So we write dichlorine. But for the second element that is associated with the compound, you put heptoxide. So this one you change the ending, but for the first one, you don't change the ending. Okay. And then another question was, then how do you know when to use these prefixes? Like, why do we use it for these? Why can't I use it for like monobromine, trichloride, or something like that? So basically that's when the rule of ionic versus compounds come in. So I want you to kind of look through your notes, tell me which one. So we have ionic compounds and then we have covalent compounds. So tell me which one uses the prefixes and then which one doesn't. Covalent, good job. Yes, so I'll write it right here for you guys to kind of make that distinction. Yeah, so whenever you're working with covalent compounds, you will be using the prefixes. When you're working with ionic, you will look at the charges and then you'll do the mix matching thing. So now let's finish this one. So we have B. What is B? Yep. So it is boron, and then we have, and again, just make sure you are aware of the charges. Okay. I know we spent a lot of time on the formulas, but it's okay. Like, let's do a few more and then we'll close the deal. And then we can do the electron dot structures next time. Because I want, like, even if this is like new material, I want you guys to fully understand it. Instead of me going over everything that I plan, like that doesn't matter as much. What matters is you get a deeper understanding of what we cover. Okay, there's a few questions in the chat. Okay, so basically the question is, how do I know what is covalent versus ionic? Like, do we look at the compound? How will you distinguish it? So I know that Dr. Tran kind of went over it in the beginning of the lecture when she was making distinctions about covalent and non-covalent. So I'll give you a hint, but you will determine which one it is. So when you have non-metal with non-metal, it's one thing. When you have metal with non-metal, that's another thing. So you can either do a Google search, you can look at your lecture notes and then make the distinction, and then I'll kind of add all those notes here. So one of them has non-metals. So you'll have a compound with non-metal elements, 2 of them. And then for the other one, you'll have a non-metal and a metal. So tell me which one is which. And again, no question is a dumb question, guys. Every question is valid. So don't hesitate when you're asking questions. I actually, in fact, love questions. See, you answer your own question. Good job. Basically, when you have non-metal with non-metal, it's going to be covalent. And when you have non-metal with metal, then it's ionic. See, magic. Yeah, so it's good. You're asking your questions and I'm redirecting back to you guys and you're answering your own questions. That's good. We'll be independent learners by the end of the semester. Yeah, so did we do those ones? Okay, looks like we did these ones. So we did 8 and then 9. So now let's do this one. Barium and, oh, kind of answered it, but work on it independently and then we'll discuss it. Okay, so we can work on it together. So we'll work on this for like next 30 minutes, but then I want to take as many questions that you guys have for like this content. I know this is like a lot of new information. This is something that we don't necessarily cover in like high school chemistry. So ask as many questions as you want. Yeah, so it is barium. And then for the second part, we just put chloride. Okay, good job. So what is Cu? And again, CO3 is the polyatomic ion. So make sure you look at the worksheet for that portion. Basically, another way for you to know which one you have to look up in the polyatomic ions is like an element is going to have a lot of oxygen with it. It might have 1 oxygen, 2 oxygen, 3 oxygen. When you have those things, you know that you have to look at that. Yes, it is copper carbonate, but there is one more thing which you may not be familiar with, but let me work on it. So basically, for this, the difference is we have to put a Roman number, and then I'll explain why. So let's write the charges first. So what's the charge for copper? Do we know? And what's the charge for carbon? Yeah, so we don't. It doesn't say anything. So it's basically 1. When it doesn't have anything, we assume that it's 1. And for the carbonate, what's the charge? It's like we switch the partners, so make sure you know. Like imagine it has parentheses here. That will help. So what's the charge for carbonate? Yeah, it's this 2, right? Right here. Yep, 2 plus. Wait, so we know that. That works out. We have the formula. Now, the thing is that since copper is a transition element, it is right here. So it's right here, right? We have to put Roman numbers for this. So the rule for transition elements is we have to put a Roman number. So here, we are not going to just write copper carbonate. We are going to say copper 1 carbonate, like that. Does that kind of make sense? Yes, okay, sounds good. So now let's do this one. So this one again is our polyatomic ion. You know that it has oxygen associated with it. Let's make this our last one, and then we'll discuss what we kind of did today. It was a lot. Okay, so for the first one, it's calcium, right? And we look at this, it's phosphate. Yeah, good job. Yeah. And since this one is not transition element, we don't have to worry about the charges. And that's what's up. So kind of like my tip overall for you when you're working with formulas and naming and writing formulas, all of that jazz. Make sure you kind of know how to go from the formula to the name, and also from how you go from the name to the formula. And kind of like the 3 main things that you need to know for these kind of things is make sure you know these prefixes, especially for when you're working with covalent compounds, right? And then for ionic, make sure you have your periodic table handy and you know which line kind of corresponds to which charge, right? And once you kind of know that, also have your polyatomic chart handy for when you're working with polyatomic ions. And then I know we weren't able to get through like majority of it, but don't feel bad about it. It's totally fine. The good thing is we are going into detail about all of these matters because there's a lot that goes behind this, like, right? Like there's a lot that you have to memorize. So the good thing is we're diving deeper into it. So now I want you guys to reflect on the whole kind of session. So we went over diatomic, naming compounds and acids. I want you to reflect on this whole thing and then kind of mention what is something that you learned today and what is something that you're feeling still kind of like fuzzy on that you might want to cover later on. And then please put that here. So something that you learned, want to keep working on. And once you have that done, we'll call it the end of the session. But thank you for being my good audience by participating. Yeah, I think like what you can do to keep practicing this is, you know how today we wrote the names, just cover the formulas, try to write the formulas, see if you can kind of make a connection between them. Yes, what's your question? You can just put that in the chat. If there is something that you want to go over in the next session, like on Wednesday, do let me know. So basically the access to the recording works this way. To the students who do come to the session, I give you the recording right away. So whenever I get a notification from my cloud that it's ready to go, but I will give the recording, like the YouTube link, to all the students in the class, like a week before the midterm. But you will get it if you have been here and you were participating. Okay, so we'll call that. Okay, so the things that you learned today were like transition elements need Roman numbers. Yeah, that's a good one to know. For the other ones, you don't have to deal with Roman numbers, just the transition elements. And do mention what you want to keep working on. So next time we'll do these formulas and then we'll do electron dot symbol and then anything that comes after. Okay, so thank you everyone. I'll see you guys in lecture on Monday and then session on Wednesday.